Hello and welcome to Data Engineering with Subhadeep. In this tutorial, we will build a complete end-to-end streaming data pipeline using Google Cloud's pub/sub, Dataflow, and BigQuery. First, we will look at the high-level architecture of our pipeline. Then we will set up the necessary GCP resources, which are a pub/sub topic and a BigQuery table. Next, we will dive into the Python code for our Apache Beam pipeline. We will also discuss key streaming concepts like windowing. Finally, we will deploy our pipeline to Dataflow and see it in action. Here is the architecture of our real-time pipeline. We will use pub/sub as our messaging service to ingest streaming data. Dataflow, running an Apache Beam job, will process this data in real time. Finally, the processed data will be loaded into BigQuery for storage and analysis. Let's start by setting up our GCP resources. First, we need a pub/sub topic to act as the entry point for our data. We will create a topic named IoT_events. Second, we need a destination for our processed data in BigQuery. We will create a dataset called streaming_data and a table inside it called device_events. This is the schema for our BigQuery table. It will have 4 columns, a device_id, the temperature reading, the original timestamp from the event, and a processing timestamp that we will add in our pipeline. Now for the fun part, the code. We will use the Apache Beam Python SDK. The first step in our pipeline is to read the raw messages from our pub/sub topic. We use the built-in read from pub/sub transform for this. The messages will be read as byte strings. After reading the messages, we need to parse them. Our incoming data is in JSON format. We define a function to decode the byte string, load it as a JSON object, and transform it into a Python dictionary that matches our BigQuery schema. We apply this function to every element using a map transform. A critical concept in stream processing is windowing. Since a data stream is technically infinite, we need a way to create logical, finite chunks to perform operations like aggregations. Windowing lets us slice the stream based on time. For example, we can create a new window every 60 seconds. In our code, we apply windowing using the window into transform. Here, we are creating fixed windows of 60 seconds based on the event timestamp of our data. Before we can do this, we must explicitly assign the event timestamp to each element, which we do with a map transform. In the real world, data can be delayed due to network issues. This is called late data. Apache Beam and Dataflow provide mechanisms to handle this, such as setting an allowed lateness period, which tells the pipeline to keep a window open for a bit longer to accommodate these late arrivals. The final step in our pipeline code is to write the processed data to BigQuery. We use the write to BigQuery transform for this. We specify the table name, the schema, and set the write disposition to append, which means new data will be added to the table without overwriting existing rows. With our code ready, we can deploy the pipeline to Dataflow. We do this by running our Python script with several command line arguments. The most important one is setting the runner to Dataflow runner. We also specify our project, region, a staging bucket, and the names of our pub/sub topic and BigQuery table. Once the job is running, you can monitor its health and performance in the Dataflow user interface. You can see a visual graph of your pipeline, check metrics like element throughput for each step, and monitor the system lag to see how quickly your pipeline is processing data. The final step is to verify that everything works. We can publish a few sample JSON messages to our pub/sub topic. After a few moments, we can run a simple select query in BigQuery to see the processed records appear in our destination table. And that's it. We have successfully built, deployed, and tested a real-time streaming data pipeline on Google Cloud. Thank you so much for watching. If you found this useful, please like the video and subscribe to the channel for more data engineering tutorials. See you in the next one.